Yes, good morning, students. We will continue the topic on hydroxy compounds. Any organic compound containing a hydroxyl or OH group is called as a hydroxy compound. OH will be the functional group here. The compounds containing an OH group, they play a very important role in our body. For example, cholesterol, alcohol commonly known as cholesterol, it's an important component in our cell membrane. Retinol present in the eye, the storage form of vitamin A, it finds an important application in the functioning of our eyes also. So like these alcohols, they have application in many areas like medicine, industry, and so on. So we are going to find out how to classify the alcohols. The alcohols can be classified based on the number of the hydroxyl groups and the nature of the carbon to which the functional group is attached. So, depending upon the number of hydroxyl groups, if there is just one hydroxyl group here will be an OH group. So, if there is only one OH group attached, it will be called as a monohydric alcohol. So, alcohols in which only one OH group is present is called as a monohydric alcohol. In this case, CH3, CH2, OH. There are two carbon atoms. It comes from the derivative ethane. So it is named as ethyl alcohol, or in short you call it, an IUPAC name will be ethanol. If there are more than one hydroxyl groups present, it will be called as a polyhydric alcohol. A polyhydric alcohol. Now, for a polyhydric alcohol, if there are in this case two hydroxyl groups, it is called as a dihydric alcohol. Now, there are two carbon atoms present here. It comes from the parent ethane. And when there are two hydroxyl group, it is also called as a glycol. So how do I name this? IUPAC name of it will be ethane. If this is the first carbon atom, this is the second carbon atom, or I change it up. It will be 1,2-diol. Di stands for 2. Ol stands for alcohol. So ethane 1,2-diol will be the IUPAC name, and the common name for this dihydric alcohol will be glycol. Any dihydric alcohol are called as glycols. If there are three hydroxyl groups, so in this case you can find there are three hydroxyl groups, so it will be called as a triol. And these triols, they are also called as glycerols. Triols are called as glycerols. Now, if more than three hydroxyl groups are present, it is called as a hexahydric alcohol. If there are 6 carbon atoms present, it will be called as a hexahydric alcohol. And this is an example for sorbitol. Hexane 1, 2, 3, 4, 5, 6 hexol is an example for hexahydric alcohol. Now, if the structure is not written, only the IUPAC name is written, how to write down its structure? Look at the last term, hexol, which tells me there are 6 alcoholic groups present. The parent is hexane. So I will put 6 carbon atoms. 4, 5, 6 carbon atoms joined together by a bond, and you will have to remember each carbon atom can have 4 bonds around this. So this is hexane, comes from the parent hexane, 6 carbon atoms, in which there are 6 alcoholic groups, and these 6 alcoholic groups are present in 1, 2, 3, 4, 5, 6 positions. So let me put OH 1, 2. So this is the first carbon atom, this is the sixth carbon atom. Second, third, fourth, fifth, all contains a OH group. Right? And now to fill up the other atoms with hydrogen, this has got two bonds around this carbon. So remaining will be two hydrogen atoms. Two hydrogen atoms. And here three bonds are there. One hydrogen atom, one hydrogen atom, one hydrogen atom, one. So CH2 OH, CHOH, 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 CHOH. So this will be CHOH 4 times. That is what is written here. CHOH 4 times along with CH. This will have two bonds here. So two hydrogen atoms can be attached to it. The CH2OH on the last and the first carbon atom. This is an example for sorbitol, a hexahydric alcohol.